Hi, it's Mrs. Scarpel, and we're going to finish looking at section 4.2, applications with point slope form. So here we have example 4. To ride in a best-in-town taxi, you pay a start fee and a mileage fee. The table shows the total cost of a taxi ride for different distances. Can the situation be modeled by a linear equation? Explain. If possible, write a linear model that represents the cost as a function of the number of miles. And the reason I went ahead and read the rest of this before determining if we have a linear function is so that I can determine my input and my output. The as a function of tells me what my input is going to be. So as a function of the number of miles, that means my distance is my input, or my x, and then that my cost is my output, or my y. So when I write my linear model, I know what my output is going to be and what my input is going to be. Now, to determine if it can be written as a linear equation, I need to see if there's a constant rate of change. So for that, we're going to check what is the rate of change between the x values and what is the rate of change between the y values. And we see with our x values, we have a rate of change of +4, followed by +2, followed by +2. And I can understand if you're initially saying, well, it can't be a linear function because we don't have a constant rate of change. But let's continue and look at our y. So our y increases by 10, and then increases by 5, and increases by 5. So if we think about rate of change, that's our slope. And slope is, and I'm actually going to put this up higher so I have this space for other work. Slope is the change in y over the change in x. So we have two different changes in the y. We have a change of 10 and we have a change of 5. For the x, when we had the change of 10, we had a change of 4, and when we had the change of 5, we had an increase of 2. If we look at these ratios, 10 over 4, when simplified, equals 5 over 2. So even though that increase of 10 is different from an increase of 5, and that increase of 4 is different than an increase of 2, when I simplify that rate of change, I get the 5 over 2. So we do have a constant rate of change. And because this is an application problem, we can take this further and put it in the context of the problem, converting this to a decimal, so that'd be 2.5, or in this case, $2.50, because the y is cost in dollars, per x is the number of miles, or the distance in miles. So our rate of change is $2.50 per mile. So now we're going to write a linear model that represents this situation. So I don't know exactly what my y-intercept is, so it's not going to be very easy to just use slope-intercept form. So I'm going to start with point slope form. Y minus y1 equals m times x minus x1. And I'm going to choose a point. I'm going to use the smallest numbers in my table, the 4 and the 13, and use those for my y1 and my x1. And we have the slope as 2.50, or we can use 2.5 in our equation. So our equation will be y minus, the y value is 13, equals, our slope is 2.5, times x minus, our x value is 4. And then we can put this in slope-intercept form. We can distribute the 2.5, and we have y minus 13 equals 2.5x minus 10, and then we can add 13 to both sides. And we have a linear model, y equals 2.5x plus 3. And if we go back and we look at this, you pay a start fee and a mileage fee. So that start fee is $3, and the mileage fee is $2.50 per mile. Now we can use this model to find out how much it's going to cost us if we need to travel 7.6 miles. Since x is miles, we're going to take this 7.6 and place it for x in our equation. So we're going to have y equals 2.5 times 7.6 and add 13. So we have y equals 2.5 times 7.6 is 19 plus, oops, that shouldn't be 13, that should be a 3. Didn't copy very well. And 19 plus 3 is going to be $22 to travel 7.6 miles. Here is another example where we have an installation fee and a monthly fee for internet service. The table shows the total cost for different numbers of months. Can the situation be modeled by a linear equation? Explain. And if possible, write a linear model that represents the total cost as a function of the number of months. Again, that as a function of indicates our input. So the number of months is our input, so that's x, making the total cost the output, or the y. So if we take a look at our rate of change, x is always increasing in this table by 3, and y is always increasing by 126. Since we have a constant rate of change, this is going to be a linear, this can be modeled by a linear equation. We can define the slope, change in y over change in x, as $126 for every 3 months, or that becomes $42 per month is our rate of change. So that is the monthly fee for our internet service. Again, we do not know what the y-intercept is of this situation, so we can start with the point slope form. So I'm going to again choose the values that are the smallest and place them in my point slope form of an equation. So we have y minus, my y value is 176, equals, my slope is 42, times x minus, my x value is 3. Distribute the 42. So we have y minus 176 equals 42x minus 126. Add the 176 to both sides, and we have y equals 42x plus 50. So our monthly fee is the $42 and the installation fee is $50. And the question we're going to use the model to answer is, how many months has someone had internet service if the total cost they have paid is $806? Total cost is Y, so this time we're going to replace Y with the value. So we have 806 equals 42x plus 50, subtract the 50, and we have 756 equals 42x. Divide both sides by 42. And x equals 18 months. In our final example, we have Remy working at Towing You Auto Sales, and her pay is based on how many cars she sells each month. Based on the table below, can her pay be represented by a linear equation? If possible, write a linear model that represents her monthly pay as a function of the number of cars she sold. So once again, let's check that rate of change. And we're told function of the number of cars she sold. So X is the cars sold, monthly paycheck will be Y. So X has an increase of 6, Y has an increase of 1,500. So X is increasing by the same amount, Y is increasing by the same amount. So we can have a linear model for this situation. So our slope, or our rate of change, $1,500 for every 6 cars she sells, which breaks down to $250 per car she sells. Again, the table doesn't tell us what the y-intercept is, what her base pay is before she sells any cars. So we can start with point slope form. And I'm again going to use the smallest numbers. So we have y minus 2,500 equals 250 times x minus 6. So we have y minus 2,500. When I distribute the 250, that's 250x minus 1,500. Add the 2,500. And we have the equation y equals 250x plus 1,000. So she gets paid $1,000 every month plus an additional $250 for every car she sells. Now, if Remy wants to earn $3,500, how many cars must she sell? So that means we need to take that $3,500, replace it for y, and solve for x, since x is the number of cars. Subtract 1,000 from each side. And we have 2,500 equals 250x. Divide both sides by 250. And she will need to sell 10 cars to earn $3,500 that month.